Hey everyone, ever stop to think about the invisible forces all around us? They're pushing, pulling, and basically shaping our entire reality. In this explainer, we're going to pull back the curtain on these hidden powers and see how they're at play literally every single day. Okay, let's kick things off with a question that sounds kind of crazy. Did you know the air in our atmosphere weighs as much as an entire ocean? Seriously, we're all just walking around at the bottom of this massive ocean of air. So, why doesn't it just crush us? Why aren't we all just human pancakes? The answer, of course, is a battle of invisible forces. It all comes down to physics. And to solve this mystery, we really only need to understand two key ideas. Let's start with the big one, the most basic concept of them all. First up, a world of force. Yeah, to understand anything that's happening around us, we first have to get a solid grip on what a force actually is. It is the building block of, well, pretty much everything. So what even is a force? It's actually super simple. It's just a push or a pull. That's it. Every single time you open a door, kick a ball, heck, even when you're just sitting in your chair, you're dealing with forces. And we measure it in newtons, named after the man himself, Sir Isaac Newton. And what can a force do? Well, just about everything. A force can make something that's standing still start moving. It can bring a moving object to a dead stop. It can make something go faster, change its direction. It can even change an object's shape. Think about squishing an empty can. That's force in action. It's basically the reason anything changes its state of motion. Okay, this leads us to a really crucial idea called net force. The best way to think about it is a game of tug of war, right? If both teams are pulling with the exact same strength, what happens? Nothing. The rope doesn't move. Those are balanced forces, and the net force is zero. But the second one team pulls just a little bit harder, the forces become unbalanced, and suddenly there's movement. That's the key takeaway here. Things only change when the forces are unbalanced. All right, so we've got a handle on force, but that alone doesn't solve our big mystery about not getting crushed. We need the second piece of the puzzle, pressure. And this is where it gets really, really cool, because it turns out it's not just about how hard you push, it's about how focused that push is. Yeah, pressure is all about concentration. It's the force you apply over a specific area. You see that formula on the screen? Pressure equals force divided by area. That little equation is everything. You could have a massive force, but if it's spread out over a huge area, the pressure is actually pretty low. But take even a small force and focus it on a tiny little spot, the pressure can be immense. Here's a perfect example. A hammer and a nail. The tip of that nail is teeny tiny, right? That small area concentrates all the force from your hammer swing onto one single point. That creates an insane amount of pressure, which is exactly why it slices right through a piece of wood. It is all about that focus. Now, let's flip that idea on its head. Think about a camel in the desert. Why doesn't it sink into the sand? Because it has these huge, wide feet. Its weight, which is a force, remember, gets spread out over a really large area. This makes the pressure on the sand super low, and it can just stroll right across. See? Same amount of force, just a different area, and you get a totally different result. And this whole pressure thing isn't just for solids. It's a huge deal in liquids, too. Imagine you're diving into a pool. The deeper you go, the more you can feel the pressure in your ears, right? That's because the weight of all the water above you is pressing down. And that's exactly why something like a dam has to be incredibly thick at the bottom. It's holding back a mind-boggling amount of pressure from the deep water. Okay, we've got our clues. We know what force is. We know what pressure is. I think it's time. Let's go back to our original question and finally solve this mystery of why we aren't getting crushed by the atmosphere. So let's put a number on it. How much force is the air actually pushing on you with right now? Get this. It's about 200,000 newtons. To put that in perspective, that's literally like having a couple of elephants standing on you. I'm not kidding. It's a staggering amount of force. So that brings us right back to the big question. With the weight of multiple elephants pushing in on us from every single direction, how are we just okay? How are we not completely squished? And here it is, the big reveal. The forces are balanced. Remember that tug of war? It's the same thing. All that insane atmospheric pressure pushing in on you is being perfectly matched by the pressure inside your body, your blood, your organs, pushing out. The push in equals the push out. The net force is zero. And that's it. No crush. Pretty cool, right? So now that we've cracked the crush mystery, we can use these same ideas to explain other bits of everyday magic. For instance, have you ever wondered how you can open a really big, heavy door with just a tiny little push? Well, that's another invisible trick at play. This little trick has to do with something called moment of force, but you probably know it by its other name, torque. Torque is just a fancy word for the turning effect of a force. And the important thing to know is that it depends on two things: how much force you use, and, this is the key, how far from the pivot point you apply that force. Think about a door. The hinges are the pivot point. Now, where's the handle? It's as far away from the hinges as possible. That's not an accident. By pushing on the handle far away from the pivot, you get the maximum possible turning power, the most torque. You're using leverage to make opening that heavy door feel effortless. It's physics, not magic. So you see, all these ideas, force, pressure, torque, they aren't just things you read about in a textbook. They are literally the invisible rules that are running the show all around you, every single second of the day. Think about this. When you use a straw, you're not actually sucking the drink up. Nope, you're just lowering the pressure inside the straw, and the huge atmospheric pressure outside pushes the liquid right up into your mouth for you. Or how about those rubber suction cups that stick to a wall? Same deal. The air pressure outside is what's holding it there. From syringes to using a wrench on a bolt, it is all physics all the time. So the next time you open a door or use a straw or just, exist without being crushed, take a second. This world is a constant, invisible dance of pushes and pulls. Now that you know what to look for, what other invisible forces are you going to spot shaping your world today?